We're on section 5.1 and we're discussing calculating distance. So let v of t be the distance of an object at time t, and then the area under the graph of v of t on a time interval a and b measures the net distance traveled or displacement between time a and b. Does this make sense? We're saying that the unit of area under the graph is going to be units of t times units of v of t, and that's time times distance divided by time, and it's going to be distance basically. So examples of this, if v is equal to v0, and that means a constant speed on A and B, then region under the graph is a rectangle with area v sub 0 times b minus a, which this makes sense because if you have a constant speed and you travel and you start traveling at time A and you end traveling at time B, then you have traveled v0 or the constant speed times b minus a, the difference in time. Now, if an object starts at rest and accelerate at a constant rate of 1 meter per square second for 10 seconds, then v of t is going to be t. And the displacement, the area under the curve, is going to be 1/2 of the 10 times 10 seconds times 10 meter per second, and equal to 50. That's the triangular area underneath the graph basically. Now you're driving across Missouri. In order to stay awake, you estimate how far you have traveled from your speedometer readings. And so at 2 p.m. you're 70 miles, that's the speed limit. At 2:15 you're 65 up a small hill. 2:30 p.m. 75 miles per hour down the hill. 2:45 p.m. 55 miles per hour. And 3 p.m. you're at 80 miles per hour. You can now estimate the maximum and minimal possible distances you have traveled during this hour, right? You just you go with the maximum speed in each time interval. Look at the time intervals. So one time interval is from 2 to 2:15. Maximum speed is 70 in that time interval, which is 15 minutes. The minimum speed is 65. Now, if I go from 2:15 to 2:30, I can go, maximum is going to be 75, minimum is 65. Again, another time interval, and then you kind of figure out where you're standing. So maximum is the first time interval is 1/4 of an hour times 70. Then the second interval is between these two time, and it's 75. The third one is between these two time and 75 again, and here is 80. And so every time interval is 1/4. You multiply it through and you get 75 miles. And if I want to find the minimum, again, time interval is the 15 minutes time interval, and then the lowest speed is 65. So I multiply 65, and then the second in time interval between 65 and 75, again 65, and so on and so forth. And then you end up with 60 miles. So you're somewhere between 60 miles and 70 miles per hour if your speed between each time interval is between the speeds that you get. And this is an estimate. It's not an accurate value at all in any possible ways. And so the actual value, the estimate of the actual value is going to be between the two the values that you found. Now, I click at question 2. The table below gives the car's velocity as a function of time. Town A is 60 miles, town B is 70 miles, town C is 73 miles, and town D is 80 miles from the starting point. by estimating the minimum and maximum distance travel, you can predict the car is, now decide which town. And so we stop right here and then we come back to answer. So now that we come back, we look at the time intervals. Every time is 15 minutes, right? And let's say, looking at the values that I have, from time 0 to 15 minutes, the minimum is 60, the maximum is 75. The second time interval, the minimum is 72, and I multiply by 1/4 again, and the maximum is 75 again. The third interval, the minimum is 72, and the maximum is 78. The fourth interval, the maximum is 78 again, and the minimum is 65. And so if you add these things together and divide by 4, with the first one we get, so computing this one, we end up with 67.5. And with that one, we end up with 76.5. And looking at this, 67.5 is going to be between A and B. And then 76.5 is going to be between C and D. So it can be anywhere from there to here, basically. And D is the answer. It doesn't give us a lot.